The first three problems on the practice test want me to make a table of values, sketch a graph, find the domain and the range, and they're all exponential functions. To do the table, if the exponent is just x, like it is in problem 2, my table's going to go from -2 to +2. If the exponent has a plus or minus sign, I'm going to change the sign of the number and put that in the middle of my x column. So when I get to number 2, the exponent doesn't have an addition or subtraction. The table I'm going to do is going to start at -2 and end at 2. That's if the exponent is just a single x. If the exponent has an addition or subtraction in it, for my table, I'm just going to change the sign of the number in the exponent. In this case, the -1 I'll change to +1. I'm going to go smaller and bigger. So part of what I need to do is make a table of values. I'm going to plot the points and sketch a graph. I also need to find the domain and the range. On the test, if you get to print it out, you'll actually have a blank graph like this that you don't have to create the XY graphs like I did in the other video. But if not, you can draw something. For the domain, all exponential functions have domains of negative to positive infinity. There isn't any work for the domain, and there really isn't any work for the range. To get the range, if there isn't a number written after the exponent, the range is 0 to infinity. If there is a number after the exponent, the range is that number to infinity. So the problem that, if I'm contrasting the problems, in problem 1, there isn't a number after the exponent, the range is going to be 0 to infinity. In problem 2, there is a number after the exponent, the range is going to be that number to infinity. There's kind of two kinds of problems for the range. They're either 0 to infinity or a number to infinity, and they're a number to infinity if there's a number after the exponent. But in this case, for number 1, there's not a number after the exponent, so the range is going to be 0 to infinity, which means the bottom of the graph is going to be the y-axis, the x-axis. So I'm going to draw that in. I'm going to make a dashed line that's going to represent the bottom of my graph. My graph shouldn't actually touch that line. It should always be microscopically above that line on one side, and the other side is going to get real high. Now I need to get each of the y values, and I can do them in my head. I can do them using the table feature on my calculator. Not a lot of you have the calculator that I own, so I'm going to use my calculator, but not the table feature. So 2 exponent -1 minus 1. Either a decimal or a fraction, I'd live with this. 1/4 is the fraction. If I SD this, 0.25 would be the decimal. It says to round to 1 decimal. If you wrote 0.3, that would be fine. If you left it 2 decimals, 0.25, I'd probably leave it at 0.25. And then for my next one, I'm going to plug 0 in. Really just for that x is where I need to plug my 0 in. I get 2 to the 0 minus 1 power. And that gives me 1/2, or I could do 0.5. And then m of 1 equals 2 to the 1 minus 1 power. You can just use the table feature on the calculator if you don't learned how to do that. And then m of 2 equals 2 to the 2 minus 1 power, or you could probably do these in your head. They're not that hard. And then m of 3 equals 2 to the 3 minus 1 power, which is going to be 4. So I'm just going to plot the points. These are the x's, these are the y's, which I could call m of x. The first point is x equal to -1, y equal to 1/4, and I'm going to estimate that there. It's half of a half in some sense, 1/4 of the way up between 0 and 1, and then 0, which is here, and then up a half, and then 1, 1, 2, 2, and 3, 4. The left-hand side, the graph should always be microscopically above the x-axis, but eventually it gets so close to the x-axis that you can't really distinguish the graph from the x-axis, but there's always a microscopic gap, and the graph goes forever to the left, and then off to the right it's going to shoot up. Should actually go through the points. The next point actually would be 4,8 for what it's worth. I don't need to get that accurate. But the right-hand side here shoots up really high. The left-hand side flattens out at where the range starts, which is at 0. Problem 2, because the exponent is just x, I'm going to do the negative 2 to 2 table. For all graphs of exponential functions, the domain we did was negative to positive infinity for 100% of the graphs. And the range was either 0 to infinity, double round parentheses, or some number to infinity. In this case, it's going to be some number comma infinity because the 2 that's not in the exponent. Now for each x, I'm going to get a y. I'm going to do f of negative 2 is 3 to the negative 2 plus 2. And I'm probably going to wind up doing the decimal because the decimals are kind of nice-ish. 19 over 9 is no good for me. I'm going to hit my SD button and say this is 2.1. It's 2.1 repeating, but rounded to 1 decimal, it's 2.1. And then I'm going to do f of negative 1 is 3 to the negative 1 plus 2. Change that negative 2 to negative 1. And it gives me 7 over 3, which is actually 2 1/3, or 2.3 repeating. And again, I'm just going to round to 1 decimal. Now I'm going to do f of 0, which is 3 to the 0 plus 2. Go back and change the negative 1 to 0, and that gives me 3. Then f of 1, which is 3 to the 1 plus 2. I could do this in my head, but don't have to. It's going to give me 5. And then f of 2 is going to be 3 to the 2 plus 2, which is 11. So I made my table, wrote the domain, I wrote the range. This graph is going to bottom out at 2 on the y-axis. So if I want to draw that dashed horizontal line in, this should be the bottom of the graph. There shouldn't be any point that goes beneath this line. Technically shouldn't even be any point on that line. So the graph is going to bottom out there. It's going to get high on the right side, low on the left side. The first point, x equal negative 2, which is here, 2.1, which is barely above that dashed line. And then negative 1, comma, 2.3, a little bit higher, but not quite a half. 0, which is here, and 3, 1 and 5, and then 2, and I guess 11's about there. The left-hand side should get super, super close to this dashed line. It should always be microscopically above the dashed line. And then it gets high on the right-hand side. I usually put little arrows at my edges. Good enough for number 2. Number 3 is a fraction, so it's going to be backwards. It's going to get high on the right side, low on the left side. There isn't a number after the exponent, so the range is going to be a 0 to infinity. This number impacts the range. If there's no number there, the range is going to be at 0. So for number 3, I'm going to make my table of values. Because the exponent isn't just x, I'm going to change the sign of the exponent. Negative 2, I'm going to change to positive 2. I'm going to go smaller and bigger. For all the graphs that we do, the domain is always negative to positive infinity. And the range is either 0 to infinity, double round bracketed, or some number to infinity when there's a number written after the exponent. Since there isn't a number written after the exponent, the range is a 0 to infinity, which means the graph is going to bottom out at the x-axis. The graph should actually never even touch the x-axis. It should be microscopically above the x-axis. And this is going to be a backwards graph. It's going to get high on the opposite side. So for my first point, I'm going to do g of 0, which is going to be 1/3 to the 0 minus 2 power, parentheses fraction 1 over 3, parentheses exponent 0 minus 2. That gives me 9. Then I'm going to do g of 1 is 1/3 to the 1 minus 2 power. That's going to change that 0 to a 1. That's going to give me 3. And then g of 2 is going to be 1/3 to the 2 minus 2 power, which is 1. And then g of 3 is going to be 1/3 to the 3 minus 2 power, which is going to be 1/3. I don't know what's going to give me. 1/3 would be fine. SD it and give me 0.3, so 1/3 or 0.3. So for this y, either 1/3 or 0.3. And then g of 4 is going to be 1/3 to the 4 minus 2. Either 1/9 or 0.1. It doesn't matter to me. But the decimal version of this is going to be 0.1. So now I'm going to plot the points. The first point is 0, 9. 0 is at the origin here, then up 9. And then 1 and 3. 2 and 1. 3 and 1/3. 4 and 0.1. Those decimals get closer and closer to the x-axis, but they're always going to be above the x-axis. So I'm going to have my left side of my graph gets high. My graph should go through the points, flatten out, and it should always be microscopically above the x-axis, and that's reasonable enough. The next problems, I'm going to do the prime factor tree methods to solve. Some of these I could do in my head, but I'll pretend I can't. So for problem 4, 3 is a prime number. I'm not going to do anything to the left-hand side. I'm going to leave it 3 to the x. 81's not a prime number, so I'm going to do the prime factoring for 81, which is 3 to the 4th. Once I can get both sides written with the same base, I cross out the bases and I set the exponents equal to each other. And if there's algebra, do the extra algebra to solve for x, but there isn't there. So that's just going to be x equal to 4. For number 5, 2 on the left-hand side is a prime number. I'm going to leave the left-hand side 2 to the x plus 4. The 32 on the right side is 2 to the 5th, so I'm going to rewrite the right side as 2 to the 5th. Now I have both sides written with the same base. I'm going to cross out the bases, set the exponents equal to each other, and because the exponent isn't just x, I need to do a little bit of extra algebra to get the x isolated. None of these, if you don't make an math error, all the answers will check, so I'm not going to check these just to save time on the video. Six and 7 are fractions. The fractions I need to change to negative exponents. So in 6, this is 1 over 3 to the 1st to the x on the left-hand side. And I'm going to change that left-hand side to 3 to the negative 1 to the x. The right-hand side is 27. And the prime factoring for 27 is 3 cubed. So I'm going to make the right-hand side 3 cubed. The left-hand side, I made the fraction have a negative exponent. I still have this parentheses. To get rid of the parentheses, I need to multiply the exponent of negative 1 times x. So the left-hand side without the parentheses is 3 to the negative 1x. The right-hand side is 3. Now that I have the bases equal, I'm going to set the exponents equal to each other and do the algebra to solve for x. The algebra to solve for x is just dividing by negative 1. The left-hand side I get x. The right-hand side, positive divided by negative is a negative. The answer is going to be negative 3. 7's also a fraction. The left-hand side is really 1 over 2 to the 1st to the 3x plus 5 equals 32. As a fraction, the fraction turned into a negative exponent on the left-hand side would be 2 to the negative 1, and then to the 3x plus 5. And on the right-hand side, 32 is 2 to the 5th power. To get rid of the parentheses on the left-hand side, I'm going to go negative 1 times 3x and negative 1 times 5, so I get 2 to the negative 3x minus 5 equals 2 to the 5th. cross out the bases, set the exponents equal to each other, do the algebra to solve for x. The algebra to solve for x would be to add 5 to both sides. That would give me negative 3x on the left side equals to 10 on the right side, and then divide by negative 3. I could write x equals 10 over negative 3. That looks odd to me to have the negative buried in the denominator of the fraction. That's an okay answer. I probably would either put the negative to the left of the fraction or in the numerator of the fraction rather than leaving it buried in the denominator. But these all are individually correct answers. They all should check. And because it's a fraction, let me check. To check, I should go to the original problem, which is fraction 1 over 2, parentheses, exponent 3, and then times what I think the answer is, which is negative 10 over 3 plus 5. That's just changing that x right there to negative 10 over 3. And when I hit equals, because I get 32, which is what the right side is, I know my answer is correct. Don't have to check any of these, but it's okay to check all of them. The next couple, I have to do a prime factoring for a number that already has a parentheses. I have to do a prime factoring for a number that already has an exponent, and when you do that, you have to introduce a parentheses and then do the prime factoring. So for number 8, the prime factoring for 25 is 5 squared. Because it already has an exponent to 25, I introduce the parentheses on the left-hand side. The right-hand side, the 5, has an implied exponent of 1. The new exponent that the 25 gets needs to be multiplied by the x and the 2. The left-hand side needs to be 5 to the 2x minus 4 power. The right-hand side is going to be 5 to the first power. Now that I have the bases equal to each other, I can drop the bases and set the exponents equal. Do the algebra to solve by adding 4, which would give me 2x equals to 5, and then dividing by 2. Because it's a fraction, I'm going to check it. It takes 2 seconds to check. And I only have to check one side. So to check this, I'm going to make that x a 5 halves. I'm going to go 25 exponent fraction 5 over 2 and then minus 2. This better give me 5. And it does, so I know that that's perfect. For 9, both the 25 on the left-hand side and the 125 on the right-hand side need prime factorings, and they both already have exponents, so I need to introduce parentheses on both sides. On the left-hand side, the 25 is 5 squared. On the right-hand side, 125 is 5 cubed. So the left-hand side is going to be 5 squared to the x minus 3. The right-hand side is going to be 5 cubed to the x minus 3. Now I'm going to multiply to clear the parentheses. I'm going to go 5 to the 2x minus 6, doing 2 times x and 2 times minus 3, equals 5 to the 12x plus 9, doing 3 times 4x and 3 times 3. Once I get the bases to be the same, I just drop the bases and set the exponents equal to each other. I need to get the x's isolated, so I'm going to minus 12x from both sides to get the x on the left side. That's going to give me minus 10x minus 6 equals to 9. Then I'm going to add 6 to both sides. That's going to give me minus 10x equals to 15. I'm going to divide by negative 10, divide by negative 10. On the left-hand side, I just get my x. On the right-hand side, I'm going to reduce by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. And I'm going to put the negative in the numerator. But as long as you have a 3 over 2 with a negative somewheres, I'm okay. I better check this because it's a fraction. For the checking, I have to check both sides. The left-hand side, I'm going to do 25 to the negative 3 halves minus 3. And on the right-hand side, I'm going to do 125 to the 4 times minus 3 halves plus 3. Separately each side. So left-hand side, 25 exponent fraction negative 3 over 2 minus 3. Might be an ugly number. Yes. 1 over 1953125. I think I remember that number. And then the right-hand side, 125 exponent 4 times fraction negative 3 over 2 plus 3. And I get that same number, 1 over 1953125. So I know my answer is right. All of these are checkable. You don't technically have to check any of them. If you don't make a math error, the answers will check. There's not much left, but I don't have enough time here to do the next problem, so I'm going to start and finish this in a part 2.